All right, so we're going to continue with chapter 2, section 5. The first part of this is in another video where I go over vertical and horizontal shifts. Today we will be going over reflections over the x and y axes and vertical stretch and shrink. So again, we went over vertical and horizontal shifts in part 1 of this lesson, but I'm going to quickly go over just the idea of what we're trying to do here. Now, in all of these examples in this lesson, we should at least know what each of these functions look like, right? So for this one, number 7, right, we know that this is a cubic function, right? We see a cube, right? So this is going to look something like this, right? And again, you can find this in the previous lesson. It's going to look something like that, right? This we said had a snake shape, right? This is what we call our parent function, all right? And now where it goes from here depends on the number that's being added or subtracted in the parentheses and the number that's being added or subtracted outside of the parentheses. On the inside of the parentheses, this is our horizontal shift. Horizontal, all right, shift, and this moves left or right. If it's on the inside of the parentheses, the sign that you see, it's going to tell you to do the opposite of what you think it will, right? So if it's a minus, you would think it would go to the left. This is going to go to the right 3 units, right? So right 3 units. Now the number on the outside of your parentheses that's being added or subtracted, this is a vertical shift, right? A vertical shift. And this, whatever sign that you see, is the direction that you're going in, right? So if it's a +2, you are going up 2 units, right? So what do we do with this parent function right here? We're going to take this parent function and we're going to drag it 3 units to the right, right? So I'm going to pick a couple points, right? So this one, and this one, right? Again, in the previous lesson, we see that we can plot maybe a couple points just to get an idea of what our graph looks like. I'm going to take these points, I'm going to move it 3 units to the right and 2 units up, right? So we end up maybe right here, and right here. And it's going to look something like this, right? So this is our transformed, our translated function. All right, so that was recap a little bit. You can find the previous lesson for more details and more examples. I work out all of the examples 1 through 8. Now we're going to talk about reflections. So if you look at these functions that you see on the screen, notice that they all share something in common. Right, so I'm going to go ahead and highlight. They all have this negative. Right, and these first four have the negative kind of on the outside of our parent function. And this last one, notice that the negative is on the inside of our parent function. Right, if you see that the negative is on the outside of your parent function, this is a reflection across the x-axis. Right, so what does this mean? Well, let's look at f of x as negative x squared. Right, this graph is going to look, right, so I'm just going to roughly sketch it. It's going to look something like this. I have an x here and a y here. We know that this is going to look something like this. Our original function, right? So this is our parent, right? A reflection across the x-axis, right? This is the x-axis right here, right? So we're going to take every single point on this parabola and you're going to flip it downwards, right? So it's going to look something like that. And this is our reflection across the x-axis, right? And it's going to work the same way for all of these functions, right? So the absolute value, right? So if you want to reflect that over the x-axis, right, it's going to look something like this. Again, rough sketch. We know that an absolute value function, right, so this is for negative absolute value of x. We know that our parent is going to be this V shape, something like that. And a reflection across the x-axis, you're going to take every single point on this V shape and you're going to flip it downwards. Right, so it's going to be something like that. All right, every single one of these, you're going to take it and flip it downwards, right, across the x-axis. Now the difference between these and this last one right here, notice the placement of the negative. In all of these first four, the negative is on the outside. In this last one, the negative is under the radical with the x, right? And it doesn't exclusively have to be just a square root function, right? Even if you had, let's say, f of x is absolute value of negative x, right? Or f of x is negative x cubed, right? Any of these. You can still use these and consider them as reflections across the y-axis, right? The reason we maybe don't see it here is because reflecting this is going to make it look similar to the original function, right? So we'll learn more about that later on, right? That they're symmetric about the y-axis, or whether they have origin symmetry. We might learn that down the line, right? But at the very least, I'll show you what f of x is the square root of negative x does, right? So I'm going to draw something like this, right? So x and y. We know that the square root of x, the parent function of that, is going to look something like this, right? We know that it's this halfway sideways parabola, right? And if it flips across the y-axis is right here, all right? So then we want to take every single point on our original parent function and we're going to flip it across and it's going to look something like that, right? Pointing in that direction, right? And this is our reflected function, right? So if these are kind of difficult to grasp, right, I always say, especially in class, you can make a table, right? Let's say I wanted to make a table here, right? An x and f of x table, right? If I pick, let's say, -1 to plug into the square root of negative x, we get the square root of -1, right? But -1, that's the same as just +1. So we get the square root of 1, which is 1. And then we end up at x equals -1 and y equals 1, and that gets you this point right here, right? So notice that if you plug in a negative number, it does work, right? If in general I had a square root of a negative, it wouldn't work. But because underneath the radical, we have a negative that's already there, these negatives are going to cancel each other out and you get something that works, right? So even if I wanted to plug in a +1, what happens if you plug in a +1? Well, you get the square root of -1, right? This is going to get you what? Right? This is going to get you I, right? And there is nowhere on this xy plane that you can plug in an I, right? So these values are not going to work. And in fact, any positive value for x is not going to work. So you can maybe try -4, right? That's another perfect square. And we get the square root of -4. And then we get the square root of 4, right? These negatives cancel each other out. And this gets you 2, right? So on our xy plane, we get -1, -2, -3, -4, and then we go up 2 units and we end up somewhere right there. And then from there, if you know the shape of a square root function, you can connect the dots and finish the rest, right? So you don't need a crazy amount of points. Now, of course, the more points you use, the more precise it's going to be, but you don't need a crazy amount. All right, so now let's try some examples. All right, so let's look at number 9. I like to always, right, and I always tell you guys also, always identify what the parent function is, right? Notice here we have, what is it, an x squared, right? What does an x squared look like? It's going to have that parabola shape. It's going to be that U shape, right? So we can quickly sketch it, right? Right away, we can quickly sketch it. And from there, that's where we're going to perform our transformations. I like to go one at a time. You don't have to go one at a time, right? But I like to always start with any reflections. I leave any shifting for last, right? But just so that we can see exactly what each transformation does, I'll go one at a time just to show you what each part of this means, right? So let's start with this negative on the outside. Well, we just learned from the previous slide that a negative on the outside of your parent function is going to be a reflection, right? So a reflection over the x-axis, right? So let's go ahead and do that. Take every single point on this parabola, and we're going to flip it. It's going to look something like that. All right, so that's one transformation, right? It's going to be a reflection over the x-axis. And then we have another transformation, and it's going to be this plus 2, right? Well, we learned in the previous lesson that a plus 2 on the outside of your parent function is going to be a vertical shift, right? And if it's a vertical shift, then the sign in front of your number tells you what to do. It's going to go up 2 units, right? So take every point that's in blue, and you're going to shift it up 2 units, and it's going to start right here, and then from here it's going to go down. Again, just a rough sketch, it's going to look something like this. All right, and then in red is our function, is the graph of our function f of x. All right, if you're ever in doubt of whether or not you graphed it correctly, make a table, right? X and f of x, right? Make a table and see what happens when you plug in a couple values. You don't need a crazy amount of values. You really just need a couple. So let's say I pick -2, -1. I'll pick 0 and 1. Right? We can stop there. If I plug in -2 in for f of x, remember that there's a negative on the outside. We're replacing x with -2, squaring it, and then adding 2. All right, -2 squared is going to get you 4, but we still have that negative on the outside. So we get -4 plus 2, and that's going to get you -2. And that's how we end up right here at this point, -2, 2. Or -2, -2. All right. And then in red, right, I didn't draw it perfectly, but it does cross that point. You can do the same thing with -1. Right, so negative, and then we're replacing x with -1. All right, plus 2. -1 squared is +1, but we have a negative on the outside. It's going to become a -1 plus 2, and that gets you a +1. So at -1, we cross at a y value of 1. You could do the same thing for 0. -0 squared plus 2, all right, is going to be -0 plus 2. That's just going to get you 2. And then you end up at this point right here. And then you can do the same thing for 1. And then you get -1 squared plus 2 is going to get you a -1 plus 2, which is 1. All right, and you end up at this point. And that should be more than enough to finish your graph, right? So if you have a couple points and you know that it is a quadratic and that it's a parabola, then you really only need a couple points, just enough to fill in the blanks. All right? All right, so let's do the same thing for the next one. All right, let's use our transformations. We know that this is a square root function. The parent function, again, I always like to sketch the parent function. We're always going to start at the origin. It crosses this point right here as well, and then it's going to look like a sideways parabola, half of it. Right, so this is what it's going to look like, our parent function. Now remember, there was a special case in the previous slide where we had a negative underneath the radical. Right, what does this mean we're going to do? We're reflecting it over the y-axis. Right, so this is a reflection over the y-axis. All right, so it's going to go in this direction here. All right, it's going to look something like that. All right, and again, if you aren't comfortable with that, if you aren't comfortable with making that reflection, make a table of values, right? We have x, f of x, and again, pick a few. -1, 0, and 1. If you plug in -1, we did this in the previous slide, we get -1, which is +1, so we get the square root of +1 is 1. And then we end up at this point right here. Square root of -0 is just the square root of 0, which is 0. We end up at this point right here. But if we square root -1, what is this? I, right? This is I. Nowhere on this xy plane can we fit an imaginary number, right? So this one's out and we end right here. And then again, if we know that this is a square root function, we know what it looks like, these 2 points should be enough. We can fill in the rest. All right, so I'm going to come back to 11 and 13. Let's go to number 12. All right. What's the difference between this one and the one that we just did, right, in the previous slide? All right, hopefully we can recognize that the difference is the placement of this negative. All right, so this is going to tell us to do what? All right, hopefully we know that this is going to be a reflection over the x-axis. So again, let's always graph our parent function. It's going to look something like that. All right, so there's our parent function. All right, and a reflection over the x-axis is going to be across this line right here. Right, so reflecting over this line, we're going to go somewhere like this. Right, so it's going to look like that. All right, and that's all you have to do. And again, if you're not comfortable with that, use a couple values. Here, if you were to try -1, 0, and 1, all right, -1, 0, and 1, we get negative the square root of -1, and that's -I. Again, a complex number, you can't have that. We have negative the square root of 0 is just -0, and there is no such thing as -0, so it stays 0. And then we get negative the square root of 1, right? This negative is on the outside, so we're allowed to have this. This is just going to get you -1, and it's going to end up right there. All right. All right, okay, good. So now let's look at 11 and 13, right? Let's always identify the original function, right? So in number 11, notice that this is a quadratic function, right? We know it's a quadratic just because of the square, right? Quadratic functions are going to look like a parabola. So I'm going to go ahead and sketch the parent function. It's going to look something like that. All right, so there's our parabola. And then do we have anything added or subtracted to it, right? So maybe any vertical or horizontal shifts, right? Doesn't look like it. I don't see any plus or minus. All right, are there any reflections? Again, doesn't look like it. I don't see any negatives on the outside, right? But we do have something. We have this number on the outside, right? This number on the outside means that we're going to have to stretch this function vertically, right? So there isn't a slide on it, but I'm going to write it up here. We're going to have a vertical stretch or a shrink. Right, vertical stretch or a shrink. Now for a stretch, it is a stretch if the factor on the outside of your parent function is greater than 1, it is a shrink, right, if the factor on the outside, right, is less than 1. All right, so let's take a look at this. If you have no idea what that means, right, what do I always tell you to do? Make a table of values, right? So pick a couple, right, x and f of x. All right, so let's pick maybe -1, 0, 1, and 2. All right, if you know exactly what happens, 2 points really is enough. But if you aren't quite sure, 3 to 5 is a good amount of points to use. All right, so let's start with -1. We get 2 times -1 squared. All right, -1 squared is just 1, so we get 2 times 1 is 2. All right, let's go ahead and plot that point. It's going to be at -1, 2, so right there. All right, let's do the same thing with 0. 2 times 0 squared is just 2 times 0, which is 0. All right, let's plot that point. It's going to be right there. All right, what about 1? It's going to get us 2 times 1 squared, which is 2 times 1, which is 2. And then we end up at this point right here. And we can do the same thing with 2, right? So we get 2 times 2 squared is going to get you 2 times 4, which is 8. All right, and then that's going to be way up here, right? Somewhere right there. So then if you notice, when we connect these points, right, it gets longer, right? This is a stretch. Right, so this is a vertical stretch. You're taking your original function and you're stretching it, and it's going to become a little bit longer and skinnier. Right? And we can do the same thing with the next one. Right? This number on the outside of this 1/2, right, we had said that anything less than 1 is going to be a shrink. Right? So this is a shrink, right, because it's less than 1. So we should expect it to do kind of the opposite of what it just did in the previous problem, right? We should expect it to get a little bit shorter and wider, right? But again, if you're not sure, make a table. All right. So again, I'll do the same values, -1, 0, 1, and 2. Actually, let me draw the parent function. All right, it's going to look something like that. There's our parent. Rough sketch. All right, and now for -1, we get 1/2 times -1 squared is going to be 1/2 times 1, which is just a half. We can plot that point. So at -1, we have a half, and that's going to be right there. All right, same thing with the next one. For 0, we get 1/2 times 0 squared. It's 1/2 times 0, which is 0. Right, so we're still at 0, 0. All right, we can do the same thing with 1. We get 1/2 times 1 squared. It's going to be 1/2 times 1, which is 1/2. All right, plot that point. And then do the same thing with 2. All right, so we get 1/2 times 2 squared, which is 1/2 times 4. Right, and 1/2 times 4 is going to get you 2. All right, so we can plot that point. And this should be enough to sketch your graph. Notice that it does, in fact, get shorter and wider. All right, something like that. All right, so those are all of the kinds of transformations that you're going to see. All right, and you have more problems like these in your web assignment.